I mentioned earlier that we have to sort of define the operations with vectors because we're used to using our number system that works in particular ways. But then, like I said, like when we introduce like something like fractions, right? You have to sort of treat the way that you add, subtract, and multiply all very differently. Same thing with vectors. The important thing is that when we define them, there's two ways of approaching it, right? We can define vectors and their operations. We can look at it algebraically. Or visually. Or you might want to think about it as geometrically, right? So algebraically or visually or geometrically. And the way that we can do this algebraically is sort of how you'd expect, right? So if I'm adding two vectors, for example, if I take, I think there's an example there on your one. So e.g., if u is equal to 3i plus 5j. This is where you just want to be aware of all the different notations because they'd like to mix them up a lot in terms of one time they'll use component form, one time they'll use like whatever, column form. The idea is when we're adding vectors, we add them by adding their horizontal components. Okay, so this is for addition and subtraction. This is how it works. For addition and subtraction, we add and subtract the horizontal components respectively. So we'll take this one over here. So u plus v. Now the way they write it in a particular way. That's just to show how the law actually applies. So if you're taking u plus v, the way that they would write it is that they say, okay, what's the horizontal component here? It's 3 plus the horizontal component here is 2. That would be 3 plus 2i. And then plus, we've got here 5. Now we've got negative 3j. And so that would just be 5i plus 2j. And so at this point you can think, okay, well, if that's all it is, then I can just take any other vector addition. What's the next one they do? Oh, they do a different one. That's right, we'll do a different one. It's like, let's do v plus w. Joel, what would v plus w be for this one?
Yes. I agree. I'm trying to zone down.
That's alright. Zone back in for me. So I'm looking at v plus w here.
V plus w? Okay.
So what's the horizontal components?
Horizontal components, that would be...
So horizontal is the I component, yeah? Remember? Yep. So what's the horizontal? So if you're adding 2 plus 5, yeah, you would. But remember, it's a negative 5 here, right? So.
Oh, I see. Oh, okay.
Yeah.
Okay, I see what it was.
Yeah.
Then it would be negative 3.
Right, okay, so that's kind of why they write it out like that, so you don't get confused. But over time, like if you're just happy to recognize, hey, what are the horizontal components? Add them together. That's negative 3i. And then here's your vertical components, that would be negative 5j. Yep. So the first couple of ones, if you're just like not too sure how the operation goes, this is one way you might want to write it out. But otherwise, more than happy for you to just go straight to the answer there as well. So that's kind of algebraically, right? Algebraically, we're thinking about, all right, there's these different components here. And same thing if we wanted to do subtraction here. I think there's a subtraction one on your one. U minus W column, what would that be? So what is U? What's the horizontal component of U?
3.
Yep, that's it. And the horizontal component of W? Minus 5, right? So we would just subtract them together, same idea, right? 3 minus negative 5, that would just be 8i. And then, same idea here, we're doing a subtraction, just be careful, double negatives, right? We're doing 5 minus negative 2, that would be 7w. 7j, sorry. Okay. Cool. So that's like the algebraic approach, right? Visually, what's actually going on here, right? Well, let's have a look.